Hello, I'm Bartley Carlson with Agilent Technologies. Today we have an HLD MR15 leak detector, and we're going to use it to leak check the vacuum furnace made by Ipsen. A helium leak check will become necessary if there's a leak up in your PLC of the Ipsen furnace greater than 10 micron per hour. At this point in time, we would need to connect the leak detector to the 4-line side of the high vacuum system and the roughing system. This can be found on any of the roughing lines in various locations. We do not want to be connected on the main chamber of the furnace itself. Currently, we have the helium leak detector connected to the bottom side of the blower on the vacuum pumps for this particular vacuum furnace. There are pros and cons whether you are connecting above or below the furnace based upon sensitivity, response time, and background. Either way, we want to make sure we're on the 4-line side of the diffusion pump. The diffusion pump will give us an incredibly high pumping speed for helium and cleanup within the main chamber in case there is a leak. That's one of the reasons why we do not hook the leak detector directly to the chamber itself. When using a helium leak detector, we want to check the integrity of all the vacuum components and gaskets associated with the vacuum system, starting at the mechanical pump, coming up to the blower, and through the 4-line and all the associated valves. At this time, we would want to check the diffusion pump and ensure that the diffusion pump is leak tight with the poppet valve. Let's not forget about the power feed-throughs on the main chamber, vent lines, and also the main front door of the assembly. Once the leak detector has been turned on and has gone through its normal startup procedure, we will need to connect the leak detector to the valve between the blower assembly and the roughing pump. Now we're ready to leak check our vacuum chamber. We can press test on the leak detector, which is the arrow button, and rough down the leak detector. We will hear a couple of valves take place as it transfers into fine test. Our leak detector is now ready for use, but prior to use, we should validate if the leak detector is working correctly or not. We go into the calibration screen. We can open up Read Internal Leak. This will validate that the leak detector will see the internal value of helium correctly. In just a moment, we should hear a couple of valves take place, and the leak rate reading should rise to the known value, which it is, 1.8 to the -7 leak rate. We can now close the internal leak and proceed with our leak check. If for any reason we were not meeting this particular specification, we could hit the calibrate button and the machine would self-calibrate. Now we can go into test configuration, and we have applications and application setups. We would like to engage spray method. We then go into the spray method home screen, and we can adjust a couple of different features. We will save these features as spray number 1. There are 3 different formulas or methods in which we can save that. And right now I would like to change my audible set point to 1.0 to the -9 range and hit OK. Therefore, I will not hear any audible alarm or noise unless my audible set point goes above that particular threshold. We can now go back to the home screen and begin leak checking. When we hook up a helium leak detector to the 4-line of an operational vacuum system, helium is being pulled not only through the leak detector but also through the primary pumps. And because of this, there will be a ratio as far as the response and the reading on the leak detector itself. The vacuum furnace may have a very large leak, although on the leak detector it may be represented by 100 times, if not 1,000 times, smaller than the main chamber's actual leak. The reason for this is the helium pumping speed through the diffusion pump and the primary pumps is much greater than the small sample that we are taking through the leak detector itself. We are now ready to begin leak checking a vacuum furnace. We want to ensure that we are using the correct amount of helium flow. This amount is way too much helium. We want to turn this volume down, or flow rate down, to where we have a steady stream of helium bubbles. When we have set the correct flow of helium, we can then start leak checking by opening up our main valve into our vacuum system. We start by leak checking with the fittings at the leak detector itself and work our way backwards through the vacuum system. ensuring that we touch every gasket and every fitting within the vacuum system to ensure its integrity. Make sure we cover all gaskets, all valves, gauges, and fittings. When a leak is found, we need to spend some time and correct it. Using the handheld remote option, one individual can leak check the entire furnace on their own. Now that we've completed the helium leak check of your Ibsen vacuum furnace using our helium leak detector made by Agilent, for any sales information, please contact your Ibsen local sales representative.